Hi, I'm Steve Grace with Trane University, Technical Service Training. I'm here to discuss the new opportunities made to our large water-cooled Helirotor chillers. In 2014, Trane introduced the Optimus chiller. Currently, the Optimus can be selected with either a Wye-Delta or a Trane TR200 AFD. This redesign of our conventional RTHD chiller included the addition of Tracer TU control operating systems with optional Trane TR200 adaptive frequency drive. RTHD chillers currently using the Tracer CH530 control can also be retrofitted to the Tracer TU controls, which would give the customers the ability to retrofit to the AFD. So we can see here we're looking at our Tracer TU adaptive view screen that has full functionality from the front panel, and this is the Trane TR200 AFD. This graph shows a comparison between ASHRAE 90.1 baseline efficiencies at full load and various operating efficiencies of other chillers. So let me explain this just a little bit. Over here on the left-hand side of the chart, we can see our kW per ton. And this is our ASHRAE baseline efficiency that we see right here. So the first column here is showing a typical screw with a drive. And remember, we're looking at full load efficiency comparisons here. So now the ASHRAE baseline efficiency being right here, we can see the typical screw with a drive is slightly above that. And the reason that is because the drive itself consumes a certain amount of power in order to replicate the AC sine wave using DC voltages and capacitors and everything else. So here is a typical screw chiller with a conventional starter, contactor starter here. And you can see that that is well below the ASHRAE baseline efficiency. So this extra that you see right here for a typical screw is simply because of using the drive. Now, we're also pointing out right here, this is what our efficiency of our RTWD water-cooled small dual circuit chiller that ranges in the tonnages between 80 to 250 tons, and its operating efficiencies here. Now, the next that we see is the Optimus with the AFD. So the Optimus with the AFD, actually, if we look at this, it's more efficient than the RTWD, obviously, but it's not quite as efficient as the Optimus with the Wye-Delta starter. Again, when you're running at full load, this extra power that is consumed through the drive into making our AC sine waves is noticeable when we're here at full load conditions. But all of these are well under the ASHRAE baseline efficiencies. And then finally, here's our Centrovac Series S oilless chiller that is frequency driven, and obviously there's nobody in the industry that can get down lower than that for us. But the whole purpose of what we're talking about here is on this next slide. Part load efficiency comparisons. So part load is the efficiency of using a drive, and with the conventional method of loading and unloading, using a slide valve covering or uncovering rotors internally, the drive adds yet another dimension of controllability for part load efficiencies. So here we're looking at part load efficiencies. Here's a typical screw chiller. You can see that their part load efficiency is a little above the ASHRAE baseline efficiency. Here's our Optimus with the Wye-Delta starter. So now we're running at part load, but remember that motor is still going to be turning at 3,450 RPM. Okay? The RTWD duplex at part load now is actually a little bit more efficient for the part loads, seeing how that we can only run, or we only need to run one circuit possibly at a time on a dual circuit chiller. Here's your typical screw with a drive, which its efficiencies are in a really good range right here at part load as well. But the Optimus with the AFD really puts us kind of in a range of our own here. And part of that is because of the fact that we have our conventional method of loading and unloading using a slide valve along with the frequency drive. Most chillers used for comfort cooling run more part loaded than they do at full load. And process chillers, on the other hand, typically run more full load than part load. So it makes sense that if your chiller was a part load type, the drive would provide energy savings. If your chiller is a full load runner, then the benefits of the drive are reduced. However, it should be noted that there's also the benefit of the AFD being the best method of starting the motor. The AFD brings the motor up to speed in a controlled manner without the locked rotor current spikes as with motors that use contactors. The sales engineer should discuss with his or her customer the advantages and disadvantages of each starter and choose which is best for his customer's needs. Thank you for your time.